Hello students, welcome back to my channel Concept Tech 2018. I am Dr. Sunanda Manke and we are here with online electronics laboratory video series, and in this part of the series we'll discuss the lab exercises based on registers and counters. So the assignment includes assignment on counters. Here we'll see the working of binary counter, the BCD counter, which is also called decade counter, and Johnson's counter. In the category of registers, we'll see parallel in parallel out register, and we'll see serial in parallel out shift register. This is the experimental setup where this is the trainer kit which is used for experiments. Then the DC supply is connected from this general purpose kit to the specific trainer kit. The clock input is given through this panel where we have two options. One is the pulse signal and another option is 1 Hz signal. We can connect any of the two for the experiment. Inputs are applied through switches. As you can see here, switches have two positions, high and low. So we can change the switch position and we can change the value of the input which is applied to the trainer kit. Then output is observed on LEDs. Here we have a LED driver IC. So output of the specific circuit is connected to the input of the LED driver IC and output is observed on LEDs. This is the trainer kit which is used for the counter experiments. This is the Johnson's counter. Basically we need two JK flip-flop ICs to implement 4-bit Johnson's counter. Each IC is having two JK flip-flops. So we need 4 JK flip-flops for 4-bit Johnson's counter. Then this is the binary counter, and the same counter is used as decade counter also. Then we have the shift register here. So we'll do the experiments on counters and shift registers with the help of this trainer kit. Let's do the experiment on shift register, and the IC used is 7495. As you can see, it's a 14-pin IC. Pin number 7 is ground and 14 is the power supply. This gives the internal diagram of this IC, and you can see here it consists of 4 RS flip-flop. Here we have two clock inputs, CP1 and CP2. We have a DS input, that is the serial data input is given on this pin, and then we have 4-bit parallel input P0 to P3, and the outputs are Q0 to Q3. As you can see here, they are the outputs of SR flip-flops. And we have a pin S which is the mode select pin. So when S is 0, CP1 is enabled. You can see here when S is 0, CP1 is enabled. CP1 goes as a clock and it is used as serial input parallel output shift register. That is, we'll apply input using DS and we'll observe the output on Q0 to Q3 values. And when S is 1, you can see here when S is 1, CP2 is enabled. So the second clock is given here, and in this case it transfers the parallel input to the parallel output pins. So when S is 0, it works as serial in parallel out shift register, and when S is 1, it works as parallel input parallel output shift register. Let's do the experiment of shift register in the mode parallel in parallel out. In this mode, we'll keep serial input open, we'll keep clock 1 open, CP1 open, and clock 2 will be given clock input. We'll apply input to these 4 inputs. Inputs will be transferred to output provided the mode pin is high. When mode pin is kept high, this IC works as parallel in parallel out, and this is the diagram. You can observe here 4 parallel inputs are applied and 4 outputs are observed here. This is the clock input and we have the power input here, so that we can see the working of shift register as parallel in parallel out. Let's do the experiment. Let's do the experiment of parallel in parallel out shift register. This is the IC which we discussed in the theory part of the lab experiment. These are the 4 inputs which are applied to different pins and 4 outputs taken on LED 1 to LED 4. We have applied 1 Hz clock and the power supply. We are doing this experiment on the breadboard. So when inputs are applied, you can observe the change in the output. As the switches are made high, all the LEDs at the output are high. When switches are closed, corresponding value becomes low at the output. So parallel data is transferred from input to output. We have observed the working of IC as parallel in parallel out register. We have kept mode pin at high position and clock input is given to CP2, and this is how we have observed the output. When P3 is 1, Q3 is 1. When P2, P3 are 1, Q2, Q3 are 1. When P1, P2, P3 are 1, that is transferred to Q1, Q2, Q3. So we observed here that P0 is transferred to Q0, P1 to Q1, P2 to Q2 and P3 to Q3. So 4-bit parallel input data is given to the output side. So you have seen how the shift register IC works as parallel in parallel out register. I hope you have understood its working. Thank you.